Hi everyone, see this question. Let P, Q, R, S be positive natural numbers. Given numbers are P, Q, R and S. Okay, with three exact factors, which means each of these numbers individually has three factors, it seems. Which means P has three factors, Q has three factors, like that individually has three factors consisting of 1 and also the number itself, which means in these three factors. So here R is a number, right? Let's take R. R has exactly three factors, right? In these three factors, one factor is 1 it seems, and another factor is number itself, means R it seems, and there is another factor which is a number. So in this format, the factors are present for this each of these numbers P, Q, R, S. Okay. If Q greater than P, they are given a condition Q greater than P, and both are two-digit numbers, which means P and Q both are two-digit numbers. Okay, both are two-digit numbers, and R greater than S, R greater than S, and both are one-digit numbers. So R and S are one-digit numbers. Okay, then find the value of this expression. We need to find this value of this expression. Okay, see here what kind of numbers which has only three factors, and the factors will be in this format, 1 and the number itself and one more number. See, let me tell you a small concept here. Okay, let there be a number A here. Here A is a prime number. Okay, A is a prime number. So if I take example for A, if A is 3 is a prime number, right? Okay, what are the factors of 3 here? 1 and number itself 3 here. That's all, only two factors for a prime number. So if I do square of this prime number, which means A square, how much? 3 square is 9. Now see carefully, factors of this number is 1, 3 and 9 here. Means one factor is 1 and another factor is some number, and another factor is number itself, 9 only. Let us take one more example also. Let's take 11. 11 is also a prime number, right? So factors of 11 are 1 and 11 only, two factors. If I do square of this number, a square equals 121. Now if I see factors of 121 here, 1 and 11 and 121, means one factor is 1 and another factor is some number and another factor is number itself. Now if we observe the factors here, 1 and 3 is nothing but prime number A, and 9 is nothing but A square. Same format, 1 prime number A and this number itself A square, which means what are the numbers PQRS means those are the numbers square of prime numbers, here 9 square of prime numbers, then only you will get the factors in the format one number and a prime number and number itself of which is A square. So I hope you understood the concept, right? So this PQRS is nothing but squares of prime numbers. Okay, one of the beautiful concept here. Remember this concept. Now let us see a problem here. Okay, problem. As we already know, what are the prime numbers here? 2, 3, 5, 7, 11, so on. Okay, these are the prime numbers. But the PQRS are square of these prime numbers, right? The series is 4, 9, 25, 49, 121. So this is the format of numbers which are present in PQRS, means in this series our values PQRS are present. Now let us find what are those PQRS. See here they have Q greater than P and PQ are two-digit numbers. In this format, two-digit numbers we have only 2. And also Q greater than P, from this we can understand that Q value is 49. So we got Q value is 49 and P value 25. We got PQ. Now see, R greater than S and RS are one digit. In this series we have only two numbers one digit, 4 and 9, and R greater than S. So we have R value 9 and S value 4 here. Okay. Now we need to find the expression P minus Q minus 1 by R minus 1. See here, P 25 minus Q 49 minus 1 divided by R minus S 9 minus 4. That's all. See, 25 minus 50 minus 25 by 9 minus by 5. So we got our answer minus 5, which is option number B here. Okay. Next question. See this question here, a 3-digit number ABC. So there is a 3-digit number ABC on multiplication with D. So when this 3-digit number is multiplied with a number D gives 37DD. This gives 37DD it seems. Okay. Where A, B, C, D are different non-zero digits, we need to find the value of A plus B plus C. Okay. From the question we got this condition, which means when a 3-digit number multiplied with 1-digit number given us a 4-digit number. Okay. So from this condition I can write like this, right? See, 37DD divided by D equals ABC. Same, right? Same condition. So now I can say like this, right? See, when a 4-digit number divided with a single digit number, 1-digit number, I got a quotient or answer which is a 3-digit number. I hope you are understanding. Now, from this condition only, 37DD divided by D equals ABC, we can also say one more thing. What is that? So, there is a number D which completely divides 37DD, right? See, ABC is an integer. ABC is an integer. When we will get an integer value? When denominator value completely divides numerator value only, right? So 37DD is this number completely divided by D number. So or else D is a number which completely divides 37DD. Okay, one thing we got, 37DD is completely divided by D. So I can write this 37DD as 3700 plus DD divided by D, right? Same, right? So this DD divided by D. So this 3700 is also divided by D. Then only you will get complete number is divided by D, right? Okay. So now I need to find a value of D. So I need to find a value of D which completely divides 3700. Why I am saying 3700 only? See here, if D divides 3700, automatically it divides complete 37DD by D, right? So you are getting my point, right? If there is a number D which divides 3700, automatically it divides 37DD, right? So now let us find this D value. Okay, what are the D values can be? As D is a single digit, we can get 0 to 9. Let me write 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These values can be our D values. Okay, let's see individual value here. We cannot take D value as 0. Why? Because when here a 3-digit number is multiplied with D. So if you multiply it with 0, automatically you get a 0, not a 4-digit number, right? So D is not equals to 0. And D is not equals to 1 also. Why? See, when a 3-digit number is multiplied with 1, you will get the same 3-digit number, not a 4-digit number. So that's why D is not equals to 1 also. Okay. Now let's see the remaining values. We cannot take D value 2 also. But why? See, if I take D value as 2 here, if I substitute directly in this only, 3722 by divided by D, I am getting a value quotient which is 1800 plus, which is a 4-digit number. See, when this number is divided by D, we need to get a 3-digit number, not a 4-digit number. So T is not equals to 2. See here 3. 3 not only divides 3700, how can I divide 37DD? So no. Here last 2 digits 4 divides, so this might be our number. And 5 also divides 3700. This might be a number. If 3 only not divides, how can 6 will divide? No. See 7 here. 7 5 is 20. 7 also not divides. 8 last 3 digits not divides. 9 some of the digits not divides. Now the values can be t equals 4 or t equals 5. Let us find both values also. Okay. If I take t value 4, we can get a, b, c value 3744 divided by 4. So I am getting 4 9s 36, 4 3s 12, 4 6 24. I got a, b, c value 936. Okay. Now let us find for d5 also. A, b, c equals 3755 divided by 5. So we got 5 7s 35, 5 5s 25, 751. I got A, B, C 751. Now here is the important thing we need to see in the question. See, A, B, C, D are different non-zero digits. Here, different non-zero digits. A, B, C are unique numbers. But in this here, T equals to 5 and we also got B equals also 5. So, T is not equals to 5. So, our answer D equals to 4, A, B, C is 936. We need to find A plus B plus C. 9 plus C, 9. So, A plus B plus C was 18, which is option number here C. Okay. Next question. See this question here. If n is a natural number, here they are given n belongs to natural number, then what is the sum of all distinct remainders? Sum of all distinct remainders of this expression when divided by 10 for various values of n. First, let us understand the question what they asked us to find. Okay. Here given an expression 4 power of n plus 6 power of n plus 9 power of n plus 11 power of n, right? For different values of n, we'll get different values, right? Okay. When this type of expression is divided by 10, we'll get different remainders, right? When different values of n, we'll get different remainders. Then we need to find sum of all those different remainders. Okay. You understood the question, right? Now let us find the answer. Before that, let me tell you a small concept. Let's say, for example, there is a value 11 times 12. Okay. I want remainder of this number when divided by 10. How to find 11 times 12 divided by 10? So when 11 divided by 10, you will get remainder 1. 12 remainder 1, you will get remainder 2. So 2 by 10. So the remainder is 2. Okay. Same question. 11 times 12. Now I want last digit of this number. So here the simple expression. So I'll just multiply. I get last digit. But with when there is a big number, how to find the last digit? We'll simply divide with 10, right? I hope you already know this. If you want last digit, you'll divide with 10. If you want last second digit, you'll get last two digits. You'll divide with 100. Last three digits 1000, like this. Okay. So see here 11 times 12 how much? 11 times 12 2 3 1 132 divided by 10. So then the remainder is 2. The last digit of this number is t. See, if you understand, in the both the cases I said remainder 2 only, which means whatever the number when divided with 10 will get a remainder which is same as last digit of that number. So again I'll repeat, whenever a number is divided with 10, we will get a remainder or a number which is same as last digit of the number. Means if we know the last digit of a number, then we will know the remainder of that number. Okay. I hope you understood how to find remainder for the number when divided with 10, which is same as last digit of the number. Okay. If you want, just rewind it and see. Okay. Now let's see the concept here. Now let's take the number 6 power of n. Let me take another pen. 6 power of n. Okay. 6 power of n. Here n belongs to natural numbers, right? For any value of n. For any value of n, the unit digit of 6 power n will always get 6 only. Just substitute n value 1, you'll get 6. N value 2, 36. See the unit digit 6 only, right? That is the remainder when divided by 10 only. So whatever the value of n, 6 power n remainder is 6 only. Okay. See 11 power n, 11 power n, same, right? Whatever the value of n, 11 power of n, you'll always get the unit digit 1 or the remainder 1. See, take n value 1, you'll get 11, n value 2, 121. See the last digit 1 only, right? So whatever the value of n, when 11 power n divided by 10, you will get remainder 1. So our expression became 4 power of n plus 9 power of n plus 6 plus 1, 7. Now we need to find when this expression divided by 10 different values. Okay. Now if I take, if n is even, means n values 2, 4, 6 and so on. Okay, if I take n values 2, 4, 6 and so on, then how 4 power n will become? How 4 power n will become? See, just substitute 4 square means 16, unit digit 6, means whatever the value of n which is even number, you will get last digit 6 only. Okay, now see 9 power n here. Just substitute 2, 9 square 81, means unit digit 1. So when n is even, unit digit of 9 power n is 1. So this expression, when n is even, 4 power of n, unit digit 6 or remainder 6, 9 power n, remainder 1 or unit digit 1, you got 7. 7 plus 7, 14. When 14 divided by 10, we got, let me scroll, we got 4 remainder when n is even. Now let us find if n is odd, means n 1, 3, 5, 7, these values. How this expression will become? 4 power of n. Just substitute 1 here. 4 power 1 means 4. So unit digit 4 you will get for every n value odd here. That's all. See 9 power of n. 9 power of n 9. Simply 9. That's all. So you already have 7. So this expression when n is odd, you will get 4 power n remainder or unit digit 4, 9 power n remainder 9 plus 7. So we got 9 plus 1, 16 plus 4, 20, 20 by 10 means remainder we got 0. So in the question, if you observe the question, they asked us to find sum of all distinct remainders. Here we got distinct remainders 4 and 0. So sum of these is 4 plus 0, 4 is our answer. I hope you understood the concept. Okay, next question. Now bars question. So here they have given 0.xyz bar on yz plus 0.519 bar on 19. This value they have given us 13 by 15. Okay, we need to find the value of this expression by finding xyz values. Okay, so if you see the left hand side of the equation is in form of bar format, but right hand side is in fraction format. So let us convert this right hand side also in bar format. Okay, now in the left hand side, first let us see with the bar maximum how many digits? In this value 2 digits, in this value also 2 digits. So with bar we have max 2 digits. Without bar, okay, without bar, in how many digits? Here we have 1 digit and here also 1 digit. So maximum without bar we have 1 digit. See, in this type of questions, in left hand side what format will be, means with bar and without bar how many digits? In right hand side also same format will be with bar and without bar, which means here 13 by 15 is less than 0 only, right? So if I write 13 by 0 as 15 as 0.ABC format, with bar 2 values, means 2 values, without bar 1 value. So 13 by 15 can be expressed in this format. Okay, I hope you understood how I wrote 0.ABC. Okay, now let us convert this 13 by 15 in the format of this. So how to write this 0.ABC in 13 by, in fraction format? So ABC minus without bar value divided by, with bar we have 2 digits, so 2 nines, without bar 1 digit, 1 0. This value they given us 13 by 15. Okay, denominator 990, here 15. So let us convert same denominators, 15 690, 15 690. So multiply 66 by 16, 66 by 66 numerator and denominator. So then we got 50 by 15 66 990. 36 how much? 60 plus 18 78, 7 carry forward, 36 78 plus 7 858. See, we got the value 858 after subtracting a, right? But we want in ABC this format. So how do I get in this format means just simply add this value. See, this value only they subtracted, right? So if I value 8 to 858, say I'll write this format 858 plus 8, 866 minus 8 by 990. This is the same format, right? So from this format means from these two, from this equation, I can write 0.866 bar on 2 is nothing but 13 by 15. Okay. I hope you understood how I wrote this 0.866 bar. Now we got 0.xyz bar plus 0.519 equals 0.866 bar. Directly subtract. Okay. So we have 0.xyz bar equals 16 minus 9 how much? 7. 5 minus 1 4. So 8 minus 1 3. So we got 0.357. So bar on 0.47. From this we can say x value is 3, y value is 4 and z value is 7. So we got x value, y value, z value. Find yourself the value of 2x plus 3y minus 5z. Okay. Next question. See this question. The sum of all possible products taken 2 at a time out of the numbers plus or minus 1, 2, 3, 4. Here the numbers are plus 1 and minus 1, plus 2 and minus 2, like that. Okay. Let me tell you with an example first. Let me take an example. Let the numbers are 1, 2, 3 and 4. Okay. If I subject 1 products taken 2 at a time, 1 multiplied with 2, 1 multiplied with 2, I get 2. Now 1 multiplied with 3, 1 multiplied with 3, I get the product 3. Now 1 multiplied with 4, 1 multiplied with 4, I got 4. Now if I subject 2 here, okay, 2 multiplied with 3, 2 multiplied with 3, I got 6. Now 2 multiplied with 4, 2 multiplied with 4, I got 8. Now if I subject 3 here, 3 multiplied with 4, 3 multiplied with 4, I got 12. Now they asked us to find sum of all possible, right? So if I add all these products, 2 plus 4, 5, 5 plus 4, 9, 9 plus 6, 15, 15 plus 8, 23, 23 plus 12, 35. So we got sum 35. So these are small numbers. So I just added and I found. But if they given large numbers, so that we have a formula which is R, just add all these 1 plus 2 plus 3 plus 4 and do whole square, and minus individual square means 1 square plus 2 square plus 3 square plus 4 square. Okay. Now divide with 2. See here, 4 plus 3 7 plus 9 10, 10 square means 100 minus 4 square is 16, 3 square is 9, 2 square is 4, 1 square is 1, or else you can use the formula also. Okay. 16 plus 9 25, 25 plus 5 30. So 30 divided by 2, 70 divided by 2, 35. Same answer, right? Okay. Now you guys tell me the answer for this question. Okay.